Hi friends, querying databases in natural language is one of the top applications of LLMs and AI agents. Here we have a Postgres database with 11 tables related to a music store. Here we have the schema, we have albums, artists, the tracks and other relevant information. Then we have store employees as well as the customers along with the invoice and invoice line, what they purchased. We will use a new AI agent framework from Hugging Face called SmolAgents to connect to the database and query it in natural language. All right, first let's use SQL Alchemy to connect to the database to make sure it is up and running. All right, so here is the DB URI. It's running locally. Create an engine and just run a sample query and the database is up and running. All right, now the SmolAgents framework from Hugging Face, it's very high level and super simple to use. Okay. Now in any AI agent framework, the top three concepts are the agents, the tools, and the LLMs. Okay. So we create agents by providing them the tools and the LLMs. So the LLM is used to understand the task, the plan, and the tools are used to execute the tasks. Okay. So let's create a SQL engine tool. Okay. Now here we have the template. It simply says this tool allows you to perform SQL queries on the table. And here we have the table definition, the four columns along with their data types, and then it takes query as an argument. Okay. Once we have the query, we can connect to the database, execute the query, and return the output. Okay. It's a very simple tool. All right. Now we use this template to create our database definition slash the description. Okay. So the description, just these first two lines, and then we create the inspector to access our tables and columns information. So we get all the table names and we go over each table to find out the columns they have along with their data types. Okay. So essentially what we are doing is we are going over each table, for example, the table artist, album, employee, etc., and then finding out the columns they have along with their data types. Okay. So that's what we are doing here. And then at the end, we are simply appending what arguments this tool takes as an input. Okay. So the tool is nothing but a function to do a very specific task. All right. So this is what we have as the description. Now let's update our tool description. So here we update the description, and this is what we have as our SQL engine tool description. Now we can add more information depending on how complex our database is. For example, how these tables are connected to each other, the primary keys, the foreign keys, etc. And depending on who uses it and what the use cases are, the business terminology may be different from the column names we have in the database. So we can even add the mapping between the business to the technical terminology. And also there are a number of SQL databases, each having slightly different syntax. So we can even specify which server we are using so that the generated SQL query executed without any errors. Okay. So this is the most important part really, creating the correct description with as much useful information as possible to give it to the tool. Once we have the tool, it's very simple. All right. So Hugging Face, they have two types of agents. One is called this code agent, which can generate and execute the code. The other one is React, the reason and act type of agent. Okay. So we will be using the code agent. And then we need to provide an LLM to the agent. There are three different ways we can provide the LLMs or access the LLMs. All right. So first, using the light LLM model, that's a different framework. It's a unified framework to connect to different LLMs. We can access commercial LLMs like OpenAI's Anthropic, as well as the open source ones hosted on, let's say, Olama, Fireworks, Together, so on and so forth, Grok, etc. Okay. So we have the model ID, which is simply the model name, and then using the light LLM, provide the model ID, and depending on where the model is running, if it's an Olama model, then the API base would be this localhost 11434. Okay, so we have the model, and then we simply create an agent with two minimal information, which is the tools. So we supply our SQL engine tool, and then the LLM model, which in this case is running locally using Olama. It's this DeepSeek 7 billion parameter model, the reasoning one. All right. Now this one is the most important parameter. Now, unlike the standard LLM workflows, which call LLM only once, the agents have some autonomy, meaning if they are not happy with the outcome, they can re-execute what they have done. For example, if an agent created some code and it tried to run the code and got an error, then it will recreate the code and re-execute on the database until it's get it correct. Okay, so it can get into an infinite loop. So that's why it's very important to have these checks and balances or this max steps or iterations when we use AI agents. So here we are setting the maximum number of times it can try is only 5. Okay, so once we have the agent, we can simply run it with the query in natural language. We will see examples of in a second. All right. Now the second method to supply an LLM is using the transformers from Hugging Face. So this is pretty much similar to Olama. So we install the transformers library and we download the model, and then we run the model using the transformers. Okay, similar to Olama, we simply supply the model ID and some additional parameters, which can be the device type, the maximum number of output tokens, so on and so forth. Okay, and once we have the LLM for agent, it's exactly the same. Now we can access the commercial models as well using the Light LLM framework, as I just mentioned. And the open source models, which are hosted on Grok, etc., also can be accessed by simply providing the model ID with the API base, okay, depending on who hosted their model. Now, okay, so let's run a simple query. How many distinct genres are there? It's super simple query. So we are using GPT-4o mini. All right. Now, step number 0. So remember, we set the maximum number of steps to 5. So this is the trial 1. Very simple query. It generated the query correctly, but it invoked the tool incorrectly. So as we saw here, the tool is simply a function with some arguments. Okay. So the SQL engine tool, it takes query as an argument. Okay. So whereas here, it invoked this query as a method by providing the query as an argument, which is incorrect. So it ran into this error that this tool / function has no attribute a query, which is this one. Okay, then it went back, and in trial 2, which is the step number 1, that's just where we start the count, but this time it invoked the query correctly, right? So SQL engine tool, that's our tool, and the parameter or the argument is query. So it's executed the query and got this output. Okay, so if it says standard LLM workflow, it would have stopped here with the error, right? As the agent has this autonomous power, when they see they ran into an error, they can go back and create the code and rerun. Or if it's some, let's say some research or etc., if they are not happy with the results, they can do some more research, things like that. Okay, all right. Now the third way to provide LLMs to these agents, if they are hosted on Hugging Face servers, we can use this Hugging Face API model. So here we have the model, the DeepSeek 32 billion parameter one, which is based on the Q1 model. And again, the syntax is very simple. We have the model ID, and then we create the model or access the model based on this Hugging Face API. Okay, so if you see in all these, it's pretty much the same. Either it is through these transformers or it is through this Light LLM model. Now, for the same model, the model ID can be different because that is based on who and where it is hosted. Okay, so for Olama models, we have this Olama prefix along with the API base 11434. Hugging Face, again, their model ID can be different. All right, so just be mindful of the model IDs. All right, so this is a reasoning model. We will see how it thinks also in a second. All right, we asked a simple query. Again, created the SQL query, and this time it ran it correctly the first time. Of course, obviously this is a different model. and here we have the output as 25. Now notice that the actual output here is a tuple, not an integer or a string. Okay, it's a tuple, but it figured out what we are looking for is an integer, and it parsed and provided the output. Now here we have another simple question. How many tracks have a length greater than 5 minutes, or here we have in milliseconds. Okay, so generated the query correctly, executed it, and it got this tuple. Now the LLMs are stochastic in nature, meaning every time we run we can get slightly different output, and also they think differently each time, meaning when it has this tuple, it was happy with the result and simply extracted, somehow extracted this integer and gave us the result. Whereas here it has the tuple, but this time to extract this number, it went back, it recreated the query, and with the result it is trying to extract this number. Okay, so in two different scenarios it's exactly the same, but this time it did not run any extra code, or it did not take any extra step to extract the final answer. Okay, all right, whereas here it is trying to access this number with this extra piece of code. So just be mindful of this stochastic nature of the LLMs. Okay, all right, so again we have the correct answer. Now let's run a query which require joins or multiple tables. So here we asked us another simple question. How many artists have more than 10 albums? So we have two tables, one with artist and another with albums. So as you can imagine, we can connect these two tables using artist ID and then figure out how many artists have more than 10 albums. All right, it came up with this query which is correct. So basically it's using this left join between the albums and the artist on artist ID. The query is correct, and it has this result 3. There are 3 artists who has more than 10 albums. Again, now let's see, similar to before, it's trying to extract the number 3 from the tuple, but let's look at the reasoning part, which is a more interesting one. All right, so here we have the reasoning part. All right, so here it says, so okay, so I'm trying to figure out how many artists have more than 10 albums. Okay, so first I need to count how many albums each artist has. So that's step number 1. For each artist we need to count how many albums they have. Okay, and then in step number 2, then I can figure out how many of those artists have more than 10 albums. Okay, all right, so then it going into the code, how it can achieve that. Okay, so SQL has this group by, so I can use this group by on artist ID and then use count to count the number of albums they have. Okay, and for step number 2, now I need to do the filtering to figure out how many of them have more than 10 albums. So again, SQL has this having class. I can use this having along with the where class to do the filtering. So putting it together, it used this artist ID to join the tables and do the group by, count, having, where. All right, so here is the code, and then after running the query, it got this tuple as an output. Then it is trying to think, hey, I'm expecting a number, but I got a tuple here. So again, trying to extract the number out of this tuple here. Okay, the language is interesting, so I will not go into I will not read all this for you, but you can read it yourself. So it said, I'm a bit confused because it could not extract this number from the tuple programmatically, but it know this is the answer. Okay, all right, so it says based on the SQL query executed and the consistent result from the logs, there are 3 artists who have more than 10 albums. Okay, all right, it's interesting to see the reasoning or thinking process. Now to summarize, the SmolAgents, it's a very high level, very simple to use framework. The only thing we really need to do is to the agent give this proper description. Okay, so the description includes all the tables along with the columns and the data types, and provide any additional information such as the primary keys, the foreign keys, how different tables are connected, and the business mapping between business to technical terminology, etc. All right, that's all for this video. Thank you very much.